Hello friends, it's my pleasure to welcome you for this new sub-series of Technocrat Talks. The hot topic today in industry and in engineering parlance is Industry 4.0. Being the very first talk, we are setting the context and general overview of what is Industry 4 all about. Followed by this, in subsequent talks, you will see, of course, many interviews and interactions. We'll get a pulse of what Industry 4 is in India and how it is poised to grow. So without much ado, let us start today's session on what is Industry 4. Basically, the movement called Industry 4 started from Germany and Europe side. Of course, they had their reasons to start it. In Industry 4, they have tried to package all the new nascent technologies. If you see the 9 pillars that comprise of Industry 4, that constitute the framework of Industry 4. Let us see what those pillars are. The first pillar is use of cloud technologies, dependence on cloud. The second pillar is big data analytics, use of big data and various forms of data, various new types of data in terms of quantity as well as quality. The third pillar is use of augmented reality. Fourth one is use of virtual twin and extensive use of simulations. The fifth pillar is overall grand integration of various softwares that were there in use in shop floor, in machine controls, of course ERP as well. So grand integration of all the software systems that we have had so far. Next pillar is, of course, to gather data from machine shops and machines, equipment, automation, the use of industrial Internet of Things, IIoT, and use of smart sensor. The seventh pillar is, of course, the use of collaborative robots and use of robots for what is called as adaptive automation. The eighth pillar, that is use of 3D printing, additive manufacturing, metal additive manufacturing as well as plastic additive manufacturing. And the last one is cybersecurity. Now these are the 9 pillars. One would tend to think that these 9 pillars are just some standalone technologies which are just thrown in, that if you have these, then you are Industry 4 compliant. Now otherwise, people have some big questions. Now suppose I have only 3 pillars out of 9. Am I Industry 4 compliant? So there are some such notions. And in the market, if you see, people consider Industry 4 as synonymous to determination of OEE or determination of energy monitoring or smart city kind of automation. But believe me, Industry 4 is well beyond all these. So now let us see what are these pillars for and what is their interrelation. If you see the first 6 pillars, that is cloud, big data analytics, use of augmented reality, virtual twin, grand integration of systems, IIoT and smart sensors. All these pillars point to only one thing, that Industry 4 is mostly about data automation, because all these pillars are essentially related to data gathering, data analytics, use of data. Since you have a lot of data, you need a bigger storage space, so use of cloud, which comes as a corollary. Now if you see the other pillars, there are 2 pillars, that is pillar for additive manufacturing, for example, and the pillar which is use of robots, collaborative robots or autonomous robots as they say. Now these 2 are actually the channels of output, getting output from virtual world to physical world. Now since most of data handling is done in computer, in software, in virtual world, but what do we get? We don't get anything unless we are able to connect it to the real world of manufacturing. And for connecting it, you have to have some output media, some way of connecting the virtual world to real world. So if you have, let us say, 3D printing or additive manufacturing, you are able to produce some parts or assemblies against the CAD model that is residing in the data. So you are able to realize whatever you think should be there, you are able to physically produce it. You are able to physically produce those assemblies and those parts. Okay. The same thing when it gets applied to automation, for example. Okay, because based on data, you may like to optimize the material logistics and automation, the way the automation works, the way the automation ought to work. So that aspect is handled by the other channel, which is the use of autonomous robots and cobots. Okay, so essentially these two pillars are all about getting output from the data, usable output from the data to the physical world, and they are the connecting points of virtual world to physical world. The last pillar that is remaining, that is cybersecurity, is a hygiene factor, basically. Because you are using lot of data, you are storing lot of data, you are sharing lot of data through cloud and through other media. So definitely you need stringent and very objectively defined rules for cybersecurity. So cybersecurity pillar is a hygiene factor which goes with handling of so much data. Now, if you see again pillar 1, cloud, use of cloud, because you are going to use big data. Now, big data in terms of volume of data, in terms of variety of data. Gone are the days when you had data meant only payrolls, only HR records, performance records, if you please. Okay. Nowadays, and only supplier data kind of a thing. Now, those were all the things which could have come in an Excel sheet, basically, or in a database that is called as SQL database. Okay. So all those traditional things which have been there in database. Okay. Now we are having a lot more volume and variety in the sense that we want to store movie files, pictures, GPS data, simulation data, okay, which is all huge size, humongous data. Now obviously companies cannot afford to have their own IT infrastructure to support that kind of volume of data. So there is a logical need for using cloud, where you are able to rent the resources for storing your data as well as for storing your programs and so many things. Okay, so use of cloud, and because the data has to be shared with your suppliers, vendors, customers, so you need a common platform through which the data can be shared easily, readily, of course based on authorization. So there will be strict norms of authorization. That is where cybersecurity will take care, hopefully. Okay, but the use of cloud is a logical necessity because you have so much more data now. Okay, now big data analytics, we have already spoken that volume and variety of data is there. So we have to be equipped to handle that. We have to be equipped for analyzing it. Now, when you analyze the data, there are two kinds of approaches. One is called as near real-time analytics. Okay. So for ongoing processes, if you want to have a control, your data processing and result and corrective action has to happen in real time, more or less real time. May not be in millisecond, microsecond, but at least in few minutes and hours. Okay. So that has to be the response time of the overall chain, the correction chain. Other is called as at rest analytics, where you have lot of data. You can take a deep dive in the data, you can do at leisure analytics, and you can become wiser for things to come in the future. Okay. So that's the other channel of data analytics, big data analytics, which may be realized through cloud or which may be realized through your captive hardware, which is called as edge computing. The edge which is connecting your shop floor to the cloud, if you can do some analytics within the shop floor, that's called edge computing. Okay, so you can do edge analytics within your shop floor for things that you don't want to share to others, but things that can be shared on cloud, of course you can have cloud based analytics. So that is the second pillar. Now the third pillar is very interesting, where from this augmented reality has come suddenly. Okay, because augmented reality and for that matter mixed reality to some extent, These are part of industry 4 pillar. So it's not something that has been used by industry so far. And one would wonder why this has suddenly dropped in here. Now, since we are talking of use of big data, very big data, big data means lot of clutter of data, which means that it will be increasingly difficult to throw up the right data to the right person at the right time, just the right data. Okay. Now, if you look at any of our shop floors, you see that all the walls of shop floor are cluttered with lot of displays, which nobody reads, frankly. And nobody can remember those things. Okay. We are used to seeing in North India some calendars, of course, like Kal Nirnay, there are some calendars. Not a square inch of space is spared in those calendars on both sides of the leaf, all the leaves. From yogasanas to recipes to what not, everything is there. But does anybody read those things? Can anybody refer it when he needs something? So that getting the right data becomes a very big challenge if there is so much of data. So augmented reality has been thrown in here so that the system can proactively throw just the right data to the right person at the right time. Now, what do I mean by that? Augmented reality is something like building a laptop or a cell phone functionality in a goggles. Okay, it has a camera, it has a mic, you can record movies, you can play movies, you can send emails, you can do chatting, you can do whatever we are able to do with laptop and cell phone. All those functionalities are there in the spectacles and it operates hands-free. Fine, very good. But how can one use it for worthwhile use? Now imagine that a big boss is taking a round on the shop floor. If he sees a job, the software that is supporting this augmented reality identifies what is the job and it shows him the summary of the job, when it was loaded, when it will get over, what is the built up cost so far against the cost target, whether you are likely to be red or you are likely to be green when you complete the project, and how does it match with the timelines those were there. Then it makes real sense. So in a way, augmented reality adds a kind of extra sensory perception. The boss knows things that he cannot know naturally. So in my personal opinion, that is what ought to be called AI. That is artificial intelligence, because it is beyond the natural senses, based on learning beyond the natural senses, right? So augmented reality is meant for throwing the right data at the right time to the right person. So if an operator, for instance, is taking up a job, the goggles identifies the job and it shows him the mistake which was made last time when similar job was made. Just a one-liner, not so much of data, not the whole series of work instructions, work guidelines. Then the operator is likely to follow that instruction because it is just one instruction which has come to the right man at the right time, instead of throwing it, splashing it all over the walls where nobody would read it. So that is the reason why augmented reality is there. Okay. Now, closely related with mixed reality, of course, part of this pillar. The next pillar comes, that is virtual twin. Virtual twin means you have CAD models for everything, say for machine, for cutter, for job, for tool, for fixture. Okay. And the simulation software is intelligent enough to predict things like cutting force, deflections, chatter marks, accuracies, cutter wear, so many things. Okay. So before you actually buy a machine and actually start machining and realize that you are not able to produce the quality that was required or the cycle time that you targeted, okay, you are able to do it virtually and you are able to be sure before you do the actual investment that this is possible to do. okay, from laws of engineering and from laws of physics. Okay, so that is the fourth pillar. The fifth pillar is, of course, grand integration. It's not that our shop floors have not been having the software systems or the data. Whatever data was found necessary, people had it. Whether the acquisition was automated or it was collected manually is besides the point. The thing is that whatever were A class and B class items for the business, those data have been there, and those must have been there because businesses cannot be so dumb that they will run without data all the way. So data was there, but there were data silos. The data was spread all over in different islands and they were not interconnected. So in industry 4, it is assumed that all those data islands will get interconnected so that top floor can talk to shop floor system, which can talk to PLC in the machine, CNC in the machine, and there is a grand integration of all the software entities that we have in the chain. Okay, so that is harnessing the advantages of grand integration. The first part is, suppose you did not have data or you do not have data or you want to automate the data acquisition. There is increasingly use of smart sensors and Internet of Things, industrial Internet of Things, to get the data directly from horse's mouth, from the machine, from the equipment, from the cutting tool, from the fixture, from the automation, from the CMMs, from the inspection data. Since we are talking of use of cloud extensively, we have in this pillar some smart sensors which can bypass the complete shop floor administration and directly throw data on cloud. Now those are smart sensors which could be used to monitor the performance of your sub-suppliers or vendors or dealers without them knowing much about what you are able to see. So that is the sixth pillar. I have already spoken about the two output pillars which are interconnecting the virtual world to physical world. And of course, the last pillar that we have spoken is cybersecurity. Now, these are the 9 pillars that constitute Industry 4.0 framework. But the question is, are these 9 pillars isolated? What happens beyond these 9 pillars? What do we get with these 9 pillars? Having 9 pillars is fine, but then what is the end effect? What is the outcome? We can have a lot of data, but what is the purpose of that data? The purpose ought to be some improvement in the way we work, some improvement in our performance, in our competence, in our intelligence level, in our knowledge bank. Something has to improve. Otherwise, what use is having the data, having a lot of data? So, it is not part of Industry 4 yet, but these 9 pillars will one day have a roof on top, which is interconnecting all the 9 pillars and which is sitting on top as the next floor, you can say, as the next level. And that next level is artificial intelligence and machine learning, AIML. Okay, because otherwise you have been doing these things. You have not that we have not been having data, not that we have not been monitoring OEE or productivity or TPM or ISO standard. We have been having all these systems in the shop floor for ages now. So other than automating it, what more do we get when we do Industry 4? So we have to naturally get something and we have to expect something that was heretofore not possible. Now that kind of thing can only be thrown up if whatever data you get, whatever big data you get, if you are able to subject it through AIML. And if you are able to drive improvement through AIML route. Because that is something which has been not there before. Industry 4 will become viable and it will make commercial sense only once we have the complete loop. So I hope I have answered the question that what will happen if I have just 3 pillars of 9. Okay. The roof will not be able to sit on 3 pillars. It will need mostly all 9, if not 9, at least 6, 7 of them. And that AIML has to drive output in 2 ways. There are 2 channels of output. One is the postmortem type of analytics, which will make you wiser for the next similar project to come. Now that is called as predictive improvement. So you predict, you learn, and those learnings you carry out in the future project to do it better. Now the other part is adaptive channel, where we can't afford to even let the current project suffer. So on the ongoing work, we want to do the improvement dynamically as the work is happening. So for that, we also need an adaptive channel of driving improvement through all these 9 pillars. Now one would say that, okay, adaptive things have been there. You have had PID controls, closed loop controls, feedback systems. What were they doing? They were doing that only. Now one has to differentiate between what is a signal and what is data. See, a sensor will give you a signal. But if you are able to archive the summary of that signal to use it later by many people many times, then it becomes data. Otherwise, it is used autonomously by local hardware, by local electronics to do adaptive correction locally. Now that becomes an electronic closed loop control only. That has been there. But now we are talking of doing similar thing with data. And data meaning the shop floor management data, inventory data, productivity data, OEE data also, of course, energy consumption data, and also suppliers response time data, and all the business variables, those are there superimposed. So all the business level data too could be integrated in the similar way. Now, when the closed loop control starts happening through data rather than through signal, that is the difference which Industry 4 will make. This is Industry 4. Now, no sooner than Germany declared this Industry 4 concept, it echoed in various avatars from various parts of the world. They call it by different names. Somebody calls it digital manufacturing, somebody called it smart manufacturing, somebody called it project catapult, and so on. There are many different names, but the concept remains same everywhere. The thing is, the way it is put, it is focused around manufacturing. But by no means these concepts are restricted to only manufacturing. You can apply Industry 4 to health services, something similar. But of course, 9 pillars can be slightly different. Maybe instead of robotic automation and 3D printing, you have some other output channel there. Or you can apply similar concept for even defense services. You can apply it for defense also. You can apply it for, let's say, navigation of aircraft and ships and space technology in a similar way. Okay. So it has a very wide scope, and government has taken cognizance of that. They are taking it very seriously. Of course, they have made some framework which they choose to call it as DESI, DESI, where these letters are some acronyms for some other things like digitalization, etc. But of course, we engineers and technocrats can build a lot around that framework to make it match with this 9-pillar model, that is Industry 4, and how to translate it for various sectors other than manufacturing industry. Okay, so it's a very big scope, it's a very big ask, it's a very big opportunity for the people associated in these kind of technologies to expand their wings, and only sky is the limit.